in the cube dancing around talking to myself. And I also want to say Ryan has got maybe the best voice for radio of any webinar I've ever listened in on. Literally, it's better than NPR. And so, to jump right into this, my name is Russ Thomas. Like I said, I've been working with databases since 1997. You can see that up here. There's a bunch of other stuff here that you probably don't care about. But the point is I've been working with databases for a long time, and I've worked with databases from a lot of different standpoints, both as an administrator, as a developer. I've done some hobby coding, and I just generally enjoy this stuff. So why the title of the presentation, Performance is a Feature? That comes from this blog post right here. Jeff Atwood, who, when he wrote this post in 2011, gave an excellent, to me this is one of the mantras of software engineering, is that performance is a feature. It is not something that just happens by accident. It is not something that that people don't care about. I know that was a double negative. That was kind of an awkward statement, but what he says right here to me is key. The slower your website loads and displays, the less people will use it. Well, this goes for any software engineering or any software application, whether it's a website, whether it's a desktop application, whether it's a microservice. The slower it works, the slower it performs. Either the less people will use it, or if it's a business critical process and they have no choice, the more your phone as a DBA or as a support person is going to ring off the hook saying this thing is a steamy pile of crap and it's just too slow. So I preach this to our software engineers all the time, and and they do as well. Performance is a feature. It's a very important feature, second only to, I say, product delivery. Product delivery is the most important feature. So from the standpoint of us database people, to us, tuning T-SQL is half the fun of the job. A lot of us, that's the reason we ended up in database, SQL Server career paths, is because we really enjoy that stuff. Software engineers, they enjoy writing objects. They enjoy writing code. They enjoy writing functions. Whether it's object-oriented programming or functional programming, what they're interested in is just that creative process, that efficiency of creating something. They don't necessarily want to just write lines of code for the sake of writing lines of code. They want to see something cool coming out the other end. And so wiring up an application to a database is kind of a pain, and it always has been. And so many, I would say most modern software engineers are starting to do this through ORMs, whether it's Entity Framework or ORM Lite or Dapper or Hibernate or many other ORMs out there that you can get. And so DBAs and software engineers have kind of come to the point where they constantly butt heads over this. DBAs are like, ORMs are slow, they're stupid, I don't get the point. And software engineers, on the other hand, are saying, this is the greatest thing since sliced bread. So this presentation is going to be heavily directed at the middle. And what I mean by that is I'm not going to try and teach DBAs how to code Entity Framework, and if there's any software engineers in the group, I'm not going to try and teach them, the merits and wonderfulness of T-SQL. I am just going to try and put a path down the middle where everyone can come together in order to make sure that both sides of the fence understand each other and get the most benefit out of the reality, right? I'm a realist. I'm not a purist. I'm a realist. And I recognize that software engineering is going largely to ORMs, and it already has been for a long, long time. And so as a DBA, I'm not trying to talk them out of using ORMs. Now I'm working on how do we use them efficiently. And when organizations like Stack Overflow run their websites, one of the busiest websites in the world, on an ORM Now, granted, it's an ORM they wrote themselves called Dapper, but it's still an ORM. You know, obviously there's merit there. So, what's so great about ORMs? For developers, for software engineers, they see it as reduced lines of code. They don't have to write every time they connect to a database, connection objects and opening objects and closing objects, and then you know, creating all that stuff. So that creates reduced complexity for them. Further, C# languages like that are strongly typed, meaning you can't compare a string to a date. You can't compare a string to a number. Even if the string is 1 and the number or the integer is 1, C# won't let you do that. You know, T-SQL sometimes lets you get away with stuff like that. So it creates, you know, it just creates confusion and problems on the software engineering side. Now, I have a bunch of software engineers that tell me object-oriented is dead. Now, everyone's going functional programming these days. Whatever. I guess that's an argument for them. The fact is ORMs create objects, true programming objects, out of database objects, and it makes it very easy to work with on a code base. By doing that, those objects then create relationships. And I'm going to show some visual examples of all of this. But really, the biggest reason why software engineers love ORMs is because that's their world. They work in object-oriented C# code. To them, T-SQL is a whole nother language. Further, they look at it as almost like an assembler language. You know, sure, it has to happen at some point, but I don't want to write it. You know, that's what software engineers would say. Now, you talk to an assembler programmer, and they think, why on earth would you want to write anything else? Assembler is the truth and the light. Well, we, you know, DBAs feel that same way about T-SQL. That's why we went down this career path. So, here is just a quick view, and I have these slides, so in case my demos fail, I always put in backup slides. Let me show you what it actually looks like here in Visual Studio. This is an entity framework context. And it looks like just kind of an entity map like you would do up in Irwin or Embarcadero, you know, for any of you database architects out there. You got your relationships, your one-to-manys. Well, what's nice is, you know, as a software engineer, I can right-click here and I can say, I want to update this model, and I'm working against AdventureWorks. So, you know, any of you can do this as well. And let's just say I want to add you know, the purchasing schema, I want to add product vendor. Finish. Entity framework writes out all that code for me. It writes out all those objects. It creates the relationships. Where did it stick it? I thought it would pop up right in front of me. I didn't see where it stick it. But you can trust me, it did. The flip side of that is now that all that is written, over here on my code side, you know, here is a procedure that gets data from my AdventureWorks context. So the only code I need is I create a variable, attach it to the context, I create another variable, do this link query, and now I can loop through it with a for each. That's the only code I have to write. I don't have to do connection objects, and you know, this using is my open and close. That's as deep as I'm going to go, and probably as deep as I can go. I am not a software engineer by trade. I'm just trying to explain why software engineers love entity framework. You know, they could do all this stuff by hand and then hand code in a huge giant string of this specific T-SQL statement. But then, you know, to us that's kind of like dynamic SQL. Database guys don't like dynamic SQL because it's, you know, one kind of code inside of another. Maybe a better example is XML. You know, it's like typing an XPath query into your T-SQL statement. You know, we hate that. We'd rather just work in T-SQL. It's kind of the same for them and the C# code. So, what I would like to do is present the 5 biggest things. I think these are the most important 5 things that every DBA, every software engineer, every database architect that works in an environment with an ORM, these are the 5 things that I think that they should all equally understand and equally agree on. So, number 1, size matters. Don't let anybody tell you different. And I'm actually stealing that from Thomas LaRock. He has an entire SQL Saturday presentation, and I'm going to summarize his entire presentation in one slide. Size matters. I don't care if you aren't using an ORM or you are using an ORM. When you are creating your data types, whoops, when you're creating your data types, when you are making the lengths of your columns, you know, making it a varchar 50 when really all you need is a varchar 10, that matters. Making it a big int when it just needs to be a bit, that matters. And down here, I got a little picture. One of the guys I work with, his name is Henry Lee, awesome guy, and no, he is not available for hire. I don't know if you're listening, Henry. He sent this screenshot to one of our hardware guys a couple of months ago. So that's my entity framework trying to resync with the database. Okay, sorry. This is 3 queries that were sent to one of our production database servers. 3 queries, all from the same SPID. And if you look at the total reads, it's really 1 query. It was just sent 3 times. This is almost 1.5 terabytes of total data that this query read from disk, largely because of this problem right here. Now, you can imagine the time the time impact, you know, and you can look at it right here. We're starting at 47 minutes after midnight, and we're going to, you know, this is like a 30-minute query. All that server was doing, and this is about as nice a production server as money can buy, all that server is doing is reading data off disk, 1.5 terabytes. This database, the entire database is only, I think, a little more than 200 gigabytes in size. So it read the database end to end like 5 or 6 times to satisfy this query. Now, there's problems with the query, any query that reads the entire database 6 times, but obviously that is made an exponential problem by improper data types, improper lengths. You know, normalization matters whether you are using ORMs or not. To meet the business needs. I am not a 3rd normal purist or a 4th normal purist, but if you can use normalization to improve performance, I don't care if you're using an ORM or not. It helps, especially because ORMs have to have normalization. That this awesome map I showed you before of the entity context, these are foreign key relationships. Entity framework leveraged those to create this map. And so that's one area where most software engineers, they don't complain about a very well-organized, normalized database, because it does make their job easier. Where sometimes they do care is when they approach it from a code-first model. And what code-first is when I declare an object as a table, and then Entity Framework creates that table on the fly on the database as now a permanent object. I am not a fan of code-first, just not. But if you have that in your environment and you develop databases through a code-first methodology, just remember code-first is not equal to not my problem. You can't blame stuff on C#. You can't blame stuff on Entity Framework. In the end, the people who write it, the people who are responsible for it, still have to provide performance as a feature. So, point two where software engineers and DBAs should come together is don't ask for more than you need. Now, this lines up perfectly with size matters, because if you have improperly sized columns and then you are asking for more columns than you need, you are creating an exponential problem. You get things like reading 1.5 terabytes of data, even though you don't need near that much data. Now, the problem here is, there's nothing too controversial with point 1. The problem with point 2 is, I would say the vast majority of code samples on MSDN, many of the code samples on Stack Overflow, on blogs, equate to select star. And the DBAs and the database engineers in the crowd are, they're cringing. We've been trained as DBAs, avoid select star. Let me give you an example of this. So I'm going to bring up my little entity framework sample project. And I will open up, oops. So this procedure, what this does, you don't need to get too into the syntax here, but I'm just selecting a people object from, or I'm sorry, a people row object from the people table object. I'm joining it to the same thing in the form of salesperson, and here's my on clause, and I'm asking where a bonus is greater than what I'm passing, and then give me the people. Loop through those people and tell me who they are. In short, let me run this program. What I'm saying is, this is just a simple little program where I can pass it a number, and it will tell me everybody, all my salespeople whose bonus was bigger than that number. So, show employees whose bonus is greater than 1,000. Now, before I run this, I already have a trace ready to go here. I'm tracing my AdventureWorks database. So, show employees whose bonus is greater than 1,000. And it lists out Michelle and Linda and Jillian and all the people whose bonus is greater than 1,000. Let's take a look at the query that it, oh, you know, I forgot to start my trace. Let me do this again real quick. 1,000 should be the same list. All right, bring up the trace. Let's take a look at this query. Now, a DBA immediately is saying, do you really need all these columns? Do you need title and suffix and email promotion? Now, heaven forbid, they had like an employee photo in here in the form of a var binary that was taken with a Nikon, SLR, because Entity Framework would go get it and bring it back. So, going back to my original complaint, here's a code sample from Microsoft. Boy, how dangerous is that, trying to browse the web during a presentation. This is where they teach you how to use these queries. From student, select student. That gets the whole row. This is a very simple example. The answer to this is you should be using projection. Now, I'm not going to pretend to give you a definition end-to-end of what projection is, but as like I said, I am not a software engineer by trade. But projection is taking one object and projecting it to another object, and in the context of Entity Framework and database queries, it's almost always going to be a smaller or a more concise object. So let's see what that looks like in the code. So here's my show big bonus query. I'm going to comment that out just so I don't forget here. In the when I run this again, I'm going to uncomment out show big bonus 2. But let's take a look at show big bonus. I'm selecting that query. I'm selecting people. I'm looping through people, and I'm getting first and last name. Show big bonus 2 creates that same object like this. Sorry, like this. But then I say, instead of select people, like this one does, see, select people, I say select a new object that is made up of people first name and people last name. This is projection. And you can Wikipedia or MSDN it if you want a real definition, something more in depth. But let's see the difference of what that does. Make sure my trace is running. Rerun my little application. Show me everyone whose bonus is greater than 1,000, exact same query. But because I used projection, see, here's my resulting query now. Much better. As a DBA, this makes me happy. Here is a problem with Entity Framework and coding these queries in this form. Most software engineers have no idea what the actual T-SQL is that's being passed to the SQL Server. So a lot of software engineers, except for those who practice and truly believe in performance as a feature, don't know that projection can save huge amounts of disk reads. So point 2, use projection. And as a DBA, now that you know, if you go in and try and help someone who says they got a slow query, and you see something like this, where the ending line is select the same object that they're declaring in this from clause, you can say, you ought to use projection. you'll come across looking pretty smart. You can even give them an example of what projection looks like. Now, I'm not saying that there's never a reason to do it this way, just like there is never a reason to do a select star. You know, sometimes there is. But if you're going to break the rules, at least know that you are breaking the rules and why. So, point 3. Like I said, I have slides just in case my demos fail. Point 3. Another major problem that I see when I help people troubleshoot their C# entity framework code, or when I'm just playing around myself, is when people put link queries inside of a for each loop. Well, database administrators, database folks, they know what that is. That's called a cursor. We hate those things. There again, they exist because very occasionally there is a legitimate use for one. But if you can find a different way, it's probably a better way. Which brings me to one of my favorite sayings. Link queries don't kill performance. Software engineers kill performance. Link will do whatever it's told. The entity framework will do whatever it's told. Computers in general do whatever it's told. So if I have a code sample that does something like this, I declare an object. I set it equal to this link query. Notice I'm using projection. I'm using even some pretty complex projection with averages and all kinds of cool stuff. And then I loop through that object just like I was in that first example, but then I'm doing another query within this for each. I just created a cursor. Let's see what that looks like in practice. So I'm going to comment out my big bonus line and uncomment out my get popular products thing.
Hey, so I did have one quick question that came in while you're doing that.
Sure. Yeah.
Somebody's wondering, he says, I know there are multiple ORM frameworks. Do they all support the idea of projection?
You know what? That is an excellent question. And as I was writing this presentation, I kept reminding myself, remember, there are more ORMs than Entity Framework. I'm focusing on Entity Framework because that's a very popular one. It's the only one that they use at my place of employment. So I know that there are some ORMs that have the same concept of projection. I have played with Dapper. What I love about Dapper is still pretty much just T-SQL. They don't have like that link syntax. They create objects off of pure T-SQL statements. So in there, it would be the difference between select star versus select names. As far as the other ORMs go, I don't know off the top of my head how many of them it applies to. But like the predecessor to Entity Framework, which was linked to SQL, and Hibernate, they do, and the syntax, it's going to be similar. And I probably should definitely update my presentation I should go out and find if that's true. Excellent question. I appreciate that.
Yeah, thank you.
This one, however, I know affects all ORMs. In fact, I think Entity Framework maybe to some extent does a better job than a lot of the other ORMs. But I'm going to start a new trace here. And okay, run my little sample here. So what this, oh, that is the same one. What did I fail to comment out? Up here. So what I'm going to ask is, show me all the products whose total order amount is typically over $1,000. So what that means is when I order something for $20, is it grouped in with a bigger order that is typically over $1,000? That's a pretty standard business intelligence kind of query. So start my little console here. List products whose total order amount is typically over $1,000. Great, go. And Entity Framework is going to show me all those products. Now, obviously, this is a pretty rough UI, but it still meets the point. Let's take a look at the trace that's running behind that. It just queried that entire product table for every single row. You know, you can go up through here, the trace. It's just pestering the database to no end. Typical cursor, right? When we see that tracing on a pure T-SQL environment, you know, immediately we're like, come on, man, use set-based logic. Well, back to my original point, sometimes the problem with the entity framework is by abstracting out that code, it's not always clear to the developer what truly is happening behind the scenes on the database. And this is definitely something that all ORM suffer from. Again, well, and even Dapper could definitely suffer from this by placing that query inside of a loop. It's pretty clear what's happening here. Let me show you the actual code block again. I am declaring an object and generating a link query on the fly inside of a loop. That's a cursor. So, a better way. Now, if there are any software engineers, they're going to look at the way that I attacked this and probably say, that's a horrible way. I would contend from a performance standpoint, it's at least a better way. I'm sure that there is an even more better way. I kind of walked into that one. Okay, so let's do this again. And instead what we're going to do is I'm going to run that same query, do that same for each loop, but I'm going to say when I get a product ID from this query that meets the needs, I'm going to add it into a list object, and then I'm going to follow up with a second query saying give me all the products, and this is basically a contain statement. You know, where the list, this list that I declared contains any of the product IDs that are found in my little view object here. So let's run that. Get products. Yep. Let's restart my trace just so we have a clean slate. Okay, so again, it's asking list products whose total amount is over 1,000. Go. Should be this. Uh-oh. I must have commented something out. Typical problem here. It didn't return anything, and I'm not clear why. Get popular products to, did I comment out the right thing? Get popular products to, okay, let's try this again. See, I did something wrong here. Yep, that's fine. Go. Well, I'm going to move on just so I don't, have to debug my own code here. What would a presentation be without a failed demo, right? Really, what the point of this being is by taking this statement out of the middle of here, and by doing this contains, it would generate the T-SQL as a where product ID in statement. Now, what would be a better way? A better way would be a join. I just wanted to show that a for each, you didn't have to do a subquery inside of a for each, even if your heart was really set on a for each. You could have done just a join on products and done the grouping and everything. That would be kind of a complex link query, which so software engineers, they would much rather work in loops. I get it. That's part of software engineering, right? For each and ifs, that's kind of their bread and butter. But recognize that placing those queries inside of a for each, that does create a hit against the database. So this is what you should avoid. You should be looking for anytime they're declaring a query inside of a for each statement. Now, one thing that is kind of cool, and I am going to praise Entity Framework a little bit, and I know the Entity Framework does this better than almost all other ORMs, except for Dapper. And the reason I keep singing the praises of Dapper is because it is raw T-SQL. What complaints I have heard against Dapper is it's not as easy as Entity Framework. You still have to do a lot of T-SQL. You still have to do some of your own object creation. Point is it's really, really fast. And it is easier than the old model of just writing up your own T-SQL. So that's why Stack Overflow wrote it themselves and use it. I'm a fan of it because it communicates with the SQL Server in T-SQL from the code all the way to the end. Now there's ways to do that to make it elegant, but that's why I tend to like Dapper. Let me comment these out, and I want to show you a different for each. So this bonus query that we did before, notice how I am asking for things out of the object of this big bonus object. I'm getting the data, so this was brought down as a set. But what about when I do things like this? What this procedure will do, I sure hope, is when I query a customer, what I'm saying is I want to know everything that this customer has ordered. Well, the way AdventureWorks is set up, I have to query a table called sales order headers to get the customer ID and then relate that to the actual detail table that has the details of that order. So if I want to see all the products that a customer ordered, I have to query multiple tables. Now, again, as a database guy, I'm thinking easy, join. Software engineers are often going to do things like for each statements. Entity Framework here is kind of cool. It can leverage the foreign key and the relationship, and it generates actually some decent SQL, even though my instinct is wouldn't this create a cursor? So let's take a look at this. So this is the get orders procedure. And yes, I will definitely make this solution available for anyone who wants to download it. And I will also debug it and find out why that last demo didn't work. It worked an hour ago. I can guarantee that. So, get orders. So what I'm going to ask is enter the customer ID to list the products ordered. And then I'm going to get those orders. And I'm going to run. So, that's one I knew. That's a customer I knew off the top of my head that had a bunch of orders. Well, okay, 6. But the point is, I'm going to have to run this again because I forgot to start my trace. (11:031). Okay. The point is, check this out. SQL Server created a query against the sales order detail table, and it passed the key that links them as 70748. It figured this stuff out based on the fact that the sorry, looking at the wrong one here. That the detail, the sales order detail, has a foreign key relationship to the ordered header table. In other words, when I come through here and I hit this for each, and I go through the ordered header, and then I hit this for each, and I'm going through each detail and linking it, all this data is already connected, and Entity Framework recognizes that it can traverse that relationship to acquire that data. So if you have your indexes all well in place on your foreign keys, like a good database should, that's pretty cool, and that is definitely one of the strengths of Entity Framework, and many other ORMs will, of the larger ones at least, will do this as well. So avoid this kind of stuff, but the true killer is when you're declaring a whole new query object and running it. Again, I would have done a join as a database guy, but I'm also a realist, and I know that sometimes those T-SQL to link queries can be pretty crazy. So a major thing that I see constantly causing contention between software engineers and the database guys is, the database guy will get a report of slowness, and they will do a trace, or they'll go through the DMVs and find a query plan, and they'll say, okay, this query sucks, and they'll give it to the software engineers, and the software engineers is like, I don't know where that query is coming from, right? Because Entity Framework has abstracted all that. So how do these two groups speak each other's language? How can they help each other out so that the translation allows the software engineer to give queries to the database guys to tune, and vice versa? Now, obviously, I've been capturing stuff in trace. So as a DBA, if I am sitting side by side with a software engineer and they pass a query from an ORM, I can capture the true T-SQL that's being passed. But that takes a lot of coordination. I have to plan ahead. I have to get the DBA online, and they're busy, and they're grumpy, and they yell all the time. And inevitably, we're gonna end up having to dig through all kinds of code. Wouldn't it be much easier if I did something instead? Let's just pick one of these. I'll just go back to the original query. Now, one of the things that, again, I think is really cool about Entity Framework 6 is the ability to do this. So I'm going to run the show big bonus one, the one that we did up at the beginning. I'm going to put a breakpoint here so that the code progression stops when it gets to this point. And start. Show me all employees whose bonus is greater than $1,000. And here's my query. This big bonus is null because I just got to this block of code, but if I step past it, what's it grumpy about? Okay, they ran the query, and now I have this big bonus object that I declared up here. One of the things that is available to me just by digging down through the code is the actual T-SQL that it generated. Now this is, this is kind of a pain. I'm going to go back to like the old DOS days of programming and just say console right line big bonus dot to string. Just give me the string. What did I say about not being a professional coder? So take out that breakpoint. Let's, just by adding this, let's run this again. Greater than 1,000. And I got my results, but I also got the actual query. So if your software engineers know that they're using Entity Framework 6, earlier versions didn't make it as easy. They had you're gonna have to Google it. You had to get the actual SQL statement from I get them mixed up, the object context or the query context, but it wasn't this straightforward. That's the point. And for you other ORM users, I'm not as familiar. Dapper makes it super easy because it's just T-SQL to begin with. You know, you might be stuck with Trace on some of the other ORMs, but if you're using Entity Framework, this is a super easy way to get the select statement. So the engineer says, hey DBA, I'm having a performance problem with this query. Who cares that it starts life looking like this? It gets sent to SQL Server looking like this. So that's what you're going to send to your database architect or your DBA. Once they've tuned it or added an index, or if they say, you know, why are you querying more rows than you need, or what if you did it, you know, with a this kind of join instead of that kind of join, getting the T-SQL query back into the ORM, there is a very, very nice tool for that. It is called Stack Exchange. So I wish I had a better way, but ultimately, if you have to make changes to the raw T-SQL and give it back to your programmer, if they really want to turn it into a link statement, that may be, you know, really, truly may be their best resources. Go hit the forums and, hey, how would I turn this query into a link statement? And maybe they're a pro and they know it off the top of my head. I am going to take this opportunity to point out, however, that nothing stops you from passing raw T-SQL. Entity Framework allows that. I was going to type out some raw SQL, but you know, I've already played with fate enough trying to type live code in my presentation. But you can pass raw T-SQL. You can pass a call to a stored procedure. Now, immediately the software engineers out there are saying, but that ruins the point. Why would I use Entity Framework if I'm just going to end up typing the T-SQL anyway? Again, I'm a realist. I'm not a purist. Do what works. If you are supporting performance as a feature, who cares if it's a link query or if it's a T-SQL query? You can still put it into source control. You can still map that relational object, even if it's a stored procedure, to your context. You can still make it object-oriented. So don't get caught up in being a purist when you are trying to support performance as a feature. I guess that's my point. So, Object-to-string in Entity Framework, you know, the more modern versions, SQL Trace is always available for all the other ORMs. And with Dapper, all you've really got to do is look at the code. It's already T-SQL. And finally, my final point is both DBAs, database engineers, the support guys, and the software engineers should understand lazy loading, lazy loading versus eager loading. This is kind of a deep topic. I'm going to give you the link to the Wikipedia because it's language agnostic, it's ORM agnostic. It kind of means the same thing no matter what your environment is, but it's basically this. Remember that first query that we wrote that had in the for each loop, it was constantly pestering the database? Lazy loading is kind of like that, but it's not always bad. So let me give you an example. I'm going to Amazon, I'm looking for a phone case for my wife, and I go to the search bar and I type phone case. Do I want to wait for Amazon to go retrieve and display every single phone case that is available for purchase on Amazon? Or do I want to see the first 10 or the first 50? Obviously, me and the database both only want to give you the first 10 or the first 50. That's lazy loading. Lazy loading is often an excellent idea. It's the reason that SQL Server added offset and fetch to SQL Server 2012, because that was a major complaint, is how can we get results a chunk at a time, versus eager loading, which is give me all the data. The point being, and why I say you should go research this on your own if you are in an environment that has to support ORMs, is you should understand the concepts of lazy loading versus eager loading and understand the cases of when one is better than the other. That is definitely could be its own entire presentation. Lazy loading that saves huge amounts of data coming back to the server or coming back to the client that the user never needs, great idea. Pestering the database 150 times with individual queries for every single row when you do actually need all 150 queries, bad idea. but it's not that clear cut on the UI side. So if your software engineers and your database folks can have an intelligent conversation about the merits of one or the other and pick one that matches the use case, that's perfect. Which leads me to my soapbox. Be scientific. Don't be a purist or a Puritan. You know, and no, I'm not talking about the religious Puritans. I am a scientist, and if my number one priority is performance, then I am going to seek after high-performing solutions wherever I may find them. I am not going to cling to Entity Framework or T-SQL or Dapper or any technology because it's my preferred technology. You know, I'm not a fanboy, I guess is what I'm saying. If you are expected to deliver product and deliver features, be scientific about it. Deliver the solution that is science-based. If one comes back in milliseconds and the other one comes back in half an hour, obviously you know what you should pick. Now, if the use case says anything under 5 minutes is fine, and the one that comes back in 2 minutes is very, very hard to write, and the one that comes back in 3 minutes is super, super easy to write and support, and they both meet the use case, okay, well then make a decision based on that. In short, don't be a Puritan or a purist either way. And I'm big in that in everything in life. You know, I'm a religious guy. I believe in being a purely good husband and father. Pretty much everything else, you know, be scientific to a T. So that is my presentation, and I'm going to turn the time back over to Ryan and available for any questions. And also, I'm very, very interested in feedback. This is the first time I've given this presentation. It's on a SQL Saturday slide because I am going to be presenting this in Albuquerque at SQL Saturday, so I've decided I'd already put it on the SQL Saturday slide. I do interact a lot on Twitter. If you want to follow me, SQL Judo. My blog is at sqljudo.com, and I am putting the finishing touches on a couple of blog posts on this very same topic. One thing I have considered changing is focusing specifically on Entity Framework because, as I said, and as the question pointed out, this is very heavy in that realm, and before I sell this as a generic presentation on ORMs, I should probably go out and get better information. So I'll turn the time back over to you, Ryan.
Great, thank you, Russ. Appreciate that. So I'm glad you brought up feedback. So as soon as the webinar is over and we close the webinar, your browser should automatically open up with a survey. So if you take the time to type some comments in there and fill out the survey, we would definitely appreciate that. Take advantage of that. If you're not able to do it right away, you'll get a follow-up email with a link to the survey. You can do it that way as well. So as far as questions, first question from a little bit earlier, about halfway through the presentation, was, can you add reads to the trace?
Can you give me context? You mean, so like I'm tracing the specific SQL statements. Are you talking like disk reads?
So that was Mark V that answered that question. So if you could maybe throw another question there, or kind of comment back on that and give us some context there, then we can kind of come back to that.
So shooting from the hip, I'm guessing they're talking about disk reads, you know, and like true performance metrics in relationship to the trace. And definitely, yeah, SQL Server Profiler makes that available. The DMVs, I'm a heavy user of Atom Mechanics SP Who's Active, and you can definitely use those products to acquire the T-SQL in relationship to disk reads, disk writes. You can't get that all the way back at the Entity Framework level. You know, you would be stuck with a server-side trace.
Oh, sorry, I was on mute. Do you have guidelines for when you would use a stored procedure instead of Entity Framework code to get the best performance?
Yeah, definitely. When the science shows that one outweighs the other. you know, the software engineers, and especially the ones that I work, are always going to default to entity framework. They don't want to write T-SQL or stored procedures anymore. So the default is going to be that. But when it no longer meets the feature metrics of the performance, that's when we have to start either addressing can the link itself or the ORM code be improved, or is this a case where we have to resort to a stored procedure? So, you know, a lot of that will depend on the culture of your environment. But to me, a lot of times, if it is more than like a simple select group by union type statement, if you're getting into truly complex queries, especially if you're doing something like you know, partition row over, that kind of stuff, some of that stuff isn't even possible with the link, and so they will start tackling that through, you know, creative and clever means on the C# side, but it is something that could be handled all in a single set T-SQL statement. And so, you know, Entity Framework gets better every release. The other ORMs are maturing, but yeah, science, I guess, is my indicator, and the performance metrics. You know, I keep preaching performance is a feature. Well, you do have to define that feature too. You know, in the user story, what is acceptable amount of time for this report to return? You know, we aren't under the gun like the Stack Overflow people, where the faster the better. Anything faster is going to be better.
Let's see. Are there any SQL Server specific options that are considered to be best practices when dealing with an ORM-based application? The one specific question or example in my head is optimized for ad hoc workloads.
So Entity Framework does a pretty good job of generating, and I can't speak to the other ORMs, so that might be an excellent choice, optimizing for ad hoc workloads in some of the other ORMs. Entity Framework does a pretty good job of always structuring the queries the same and passing the variables as parameters. I wonder if that one is still up that I had before. You know, like this. It's passing this key value in to this statement. And so from what I have seen, SQL Server does a pretty good job of caching those query plans and reusing those plans. As far as other ones go, you know, it kind of comes back down to fundamentals. Entity Framework works best with simpler databases, third normal, you know, pretty vanilla stuff, especially the code first stuff. So none that I have found that are on my, you know, you have to have list. But I could definitely see optimized audit workload with other ORMs if they're not as good about you know, always structuring their queries the same, or parameterizing their queries. You know, if they're passing you know, literal values and stuff.
There's Jason's Philly stuff.
Hello?
I'm on a roll. I'm on a roll.
I was like, did I get disconnected?
Yeah, I tend to hit my mute button at the exact wrong time. So do some entity frameworks use non-performance isolation levels as default, thinking those that begin every call with begin transaction even for selects?
I have not seen that. I haven't seen a lot of the queries that I have played with, and I'll be perfectly honest, the reason that I'm doing this presentation and the reason I do many presentations is when I start experiencing problems or new challenges, you know, in my own professional career, I'll start digging in and researching it. And then once I find something I'm satisfied with, I like sharing it. I have only dealt with a lot of read-only report type queries. I haven't dug into a lot of Entity Framework update type queries that would need to use transactions. So unfortunately, I don't have a lot of expertise there, but I guarantee that will be my next blog post, because now I'm curious. Yeah, how does it do that? How when you pass an update statement, how, are they implicit transactions? I think that's an excellent question, and I will definitely answer that within the next couple weeks.
Yeah, that'd be great. And I'll send all the questions over to you within
Sure.
about a week or so. Actually, well, with the holidays, it'll probably be a couple weeks, but I'll send all the questions over to you, so that way if you wanted to blog the answers or anything like that, you can absolutely do that. I think that is all the questions that we have, and we are right at time. So, Russ, really appreciate you spending the time to talk to us today. It was a fantastic presentation. You did a great job, and we thank you for taking the time to come talk to us today.
Yeah, I appreciate it. Thank you.
And everybody, we will. In fact, Russ, if you could, if you're willing to send, any code, the slide deck, anything over to us, we'll post that on our website. And,
I will do.
And we've
I
got a
will do that
recording
this weekend.
Okay, fantastic. And we've got a recording as well, so we'll have the recording posted. At the holidays, give us, normally we say a week. You might want to give us a couple of weeks as everybody's kind of out on vacation and stuff. So, but we'll get all that stuff posted up on our website. And thanks again. We appreciate it, and we'll see you soon. Hopefully at a SQL Saturday.
Okay, I appreciate it. A lot of fun. Thanks. Bye.
Bye.